This is a noise figure analyzer model NFA10. It consists of a noise figure analyzer. It doesn't come with a CRO. You need to use an ordinary oscilloscope dual channel from the laboratory. We have connected the horizontal output from the noise figure analyzer into channel X of the CRO and the vertical into channel Y of the CRO. As you can observe, I have put this oscilloscope into the XY mode, and for better visualization I have kept the persistence as 1 second. Each of these channels has been put to a DC coupling, and the signal attenuation for this channel has been kept as 500 millivolts per division. The same is for channel number 2. Channel number 2 is also kept in DC coupling and is kept on 500 millivolts per division. The position of the channel 1 is kept at 0, and position for the channel Y has been kept at -4 divisions. The moment we hook it on, it appears to us as if it's a kind of a spectrum analyzer. Now you can see there's a grass and this is the signal. What the specialization about this noise figure analyzer is that it comes with an integrated preamplifier, and it has a very low noise figure as compared to an ordinary spectrum analyzer. Hence this is a specialized instrument, and it also has a very low frequency video filter which allows for very heavy filtration of the noise signals. This works from a frequency up to 500 megahertz and has a sensitivity of more than -90 dBs, and its input noise floor is roughly about 4 dBs, and the vertical scale has a scale factor of 500 millivolts equal to 10 dB. That means each divisions on this particular CRO right now will equal to 10 dBs. We have provided with a preamplifier with a calibrated noise figure of 3 dBs. We have also provided with an excess noise generator with a calibrated excess noise above 25 degrees thermal noise level as 12 dB. Hence its level is 12 dBs above the thermal noise floor at 25 degrees Celsius. We've also provided with some antennas and some low pass high pass filters and some terminations for you to experiment with. Now we start off with the working of the instrument. We set the center frequency to roughly 250 megahertz, and this becomes our frequency of observation for measurement of noise figure of this particular amplifier under test. The sweep we can reduce. We may reduce it sizably so that we are only observing the noise figure at one particular frequency of our interest. Now what we will do is we will hook up the output of the preamplifier into the input of the noise figure analyzer, and the moment we switch on the instrument, the moment we switch on the power amplifier, the preamplifier, we observe on the oscilloscope that the noise level has increased. This has increased because this has a huge amount of gain, and because of which the signal has risen up. You see, the signal level has risen up appreciably. Now what we can do is, in order to be able to precisely measure this noise grass, we are going to apply a filter. That filter will bring us a reference noise level. The input of the amplifier has been terminated into the excess noise generator. This excess noise generator has a built-in 50 ohm termination with a 20 dB return loss. So this preamplifier has been matched into an input impedance, and this 50 ohm termination is right now at the room temperature of 25 degrees centigrade. Hence its input is right now terminated into the normal thermal noise floor. We can position the CRO display to say the center of the display. Now the moment we switch on the excess noise generator, 12 dBs of excess noise above the thermal noise will be applied to the preamplifier. And we observe that the signal level has risen by approximately 0.9 graticouls. Show it to you again, and observe it carefully. This is right now at the center of the display, and now the signal has increased by about 0.9 dB. We have already told you that the amplification of our vertical channel is 500 millivolts equal to 10 dB. That means 10 dB is one of these graticules on the CRO. The signal level has increased now by 9 dB. 12 dB is the ENR of our noise source, and 3 dB is the noise figure of our preamplifier what we have provided. So it's a simple measurement that ENR of 12 dB equals to the noise figure of the device under test and the residual noise level measured on the display. We can increase the calibration from 500 millivolts to say about 100 millivolts. That will bring the display to about 2 dBs per division, and you may be able to measure the noise figure with slightly more precision.